Alright, welcome back. We're going to go through number 21 and 23 from 4.6b. Both of these were graphing trig functions. We talked about in class how when we see things like cosecant or secant reciprocal functions, we're going to start by thinking about graphing the reciprocal of those functions, which is the sine of pi minus x. So when we go to graph this, we need to find a few things. We need to find the amplitude, which in this case is 1, period, which is 2 pi over b. b in this case is still the one that's hanging out there, so it's 2 pi over b, 2 pi over 1, which is just 2 pi. And then we know we need to find both the start and the end point so that we can properly find our intervals. So we always start by taking the inside of the function, which in this case is pi minus x, and setting it equal to the normal start position of a sine graph, which is 0. And we're going to solve for x. So we're going to get that x is equal to pi. So there's my starting point. And then we're going to end at pi minus x is equal to 2 pi. So we're going to end, let's see, that's going to be x is equal to negative pi, because we're going to get negative x is equal to pi divided by negative 1. X is equal to negative pi. So this is kind of weird because essentially what's happening is it looks like it's going backwards. We have a start value at pi, an end value at negative pi. The good news is it doesn't really affect what we're doing, because when we look at a unit circle, if we start at pi, that means we're going from 0 counterclockwise around to pi. And if we end at negative pi, it means we're going from 0 counterclockwise, and that's just negative pi. So if I'm starting at pi and ending at negative pi, it just means I'm making a full revolution, just counterclockwise essentially. So we still have one full revolution, which means when I set up my intervals, if I start at pi and I end at negative pi, I'm just going to count backwards by pi halves. So I've got pi halves, 0, negative pi halves, and then negative pi. Well, that's all I really need to make my graph. Again, like I said, it's going to be a little bit goofy, but we'll be okay. There's my vertical axis. My horizontal axis. And then I'm going to put some labels. We're going to start at negative pi halves, negative pi, negative 3 pi halves. Go the other way. That's pi halves, pi, 3 pi halves, 2 pi, and my period was, or my amplitude was 1. We got 1 and negative 1. And because I have the same, I'll make that just a little bit thicker. Because I have the same intervals I'm counting by, nothing really changes. For sine anyway, whether I'm at 0 on the left or now pi on the right, it doesn't change what my graph looks like. The sine of pi is still 0, because my y value is 0, and my sine of 0 is still 0, and my sine of pi halves and negative pi halves is still 1 and negative 1. So when we graph this, it's really not going to look any different. We start at 0. At pi halves, I'm at 1. At pi, I'm at 0. 3 pi halves, I'm at -1. And I'm going to, nothing really changes. It just looks weird because we had that backwards, the backwards intervals. So that's my sine graph. Now we want to graph. What we actually want to graph is cosecant. So we talked about in class that we have these vertical asymptotes at our zeros. Not there. And then cosecant is just parabolas at my maximum values. So cosecant is going to be the red graph, and that's it for 21. Moving on to 23, 2 cotangent of x minus pi halves. So we already know that a cotangent graph and a tangent graph, they both have this kind of S shape. In fact, that's what I just drew as a tangent graph. So cotangent is going to look the opposite direction. It's going to look something like that. That's a really horrible graph, but we know it's going to look like that, and all we have to do is worry about where the intervals are at. Remember we said that that amplitude doesn't really affect the graph. It just makes it a little bit skinnier. But what we're going to do, a regular cotangent graph, if we think about the cotangent of a regular unit circle at 0, remember this is the point 1, 0, 0, 1, -1, 0, and 0, -1, cotangent in each of these points. So cotangent here is going to be 1 over 0, so it's undefined. Cotangent here is 0. Cotangent here is undefined. And cotangent here, down here at the bottom, is 0 again. So my regular period for cotangent goes from 0 to pi. So this is my normal starting point and my normal ending point. So all we have to do, just like the previous graph, my new start is x minus pi halves equals 0, and my new end is that x minus pi halves equals pi. So x is going to start at pi halves, x is going to end at pi plus pi halves, so that's going to be 3 pi halves. So when we draw our unit circle, we have pi halves, and we end at 3 pi halves, so this has to be pi. Well, that's good news because we don't have to change our intervals, we're just changing where our start and end points are at. So let's draw our axes. And so we're going to have pi halves, pi, 3 pi halves, 2 pi, 5 pi halves, 3 pi, 0, negative pi halves, negative pi, negative 3 pi halves. So we know that cotangent at all my, in this case at my pi's, cotangent is going to be 0, and at pi halves and 3 pi halves, cotangent is going to be undefined. So I'm going to have asymptotes, vertical asymptotes at pi halves, 3 pi halves, 5 pi halves, negative pi halves, negative 3 pi halves, and then we have zeros at pi, 2 pi, 3 pi, 0, negative pi. Then we just have to think about which direction it goes. Well, we know that all these pi fourths. What would typically be pi fourths. In general, it's whatever's between pi halves and pi, which in this case is 3 pi fourths. We know that we're going to get a cotangent of 1. So at 3 pi fourths, we're at, we would normally be at 1, but this time we're going to be at 2, so we're just quite a bit steeper. And then -2 for the other half of it. And so that gives us the general shape that we're looking for. Oop, that one I did a really bad job on. And here's my last one. There you go, and that's cotangent of, or 2 cotangent of x minus pi halves. So that's the number 21 and 23 from 4.6b.